with no more ado, I'll ask Guillaume de Pommereau to speak first. Guillaume.
Thank you, Mike, and good afternoon, everyone. So my name is Guillaume de Pommereau. It's a pleasure to be here. I chose to speak about artificial intelligence and finance based on my experience as a CFO for 20 plus years. And I will cover 4 parts. I mean, my understanding of what AI is, then how can it help finance professionals in a corporation? I will give you some practical applications that I've used in the past and that I'm planning to use in the future. And then the last section would be the next steps for a finance director. So if you are okay, I would like to have your Q&A at the end of the 10 minutes. So my understanding of what artificial intelligence is, artificial intelligence covers a wide range of old and new concepts. For instance, expert systems or robotic process automation are based on decision trees or script of instructions to automate processes, and they have been around for decades, so this is not new. But what is very new is a combination of the growing computing power available to all of us, the massive amount of data that we generate nowadays, and new powerful algorithms. Artificial intelligence is often broken down into 3 families of applications. You have machine learning, you have natural language processing, and you have robotics. They all derive their intelligence from advanced statistics technique. What AI can do intelligently as compared to a human being is extremely limited. AI does not have a conscience. It cannot understand a text. To summarize it, for instance, it cannot hold a conversation. That's what we call the Turing test. So AI is not really intelligent as such, but AI can certainly deliver huge support to humans thanks to the ability of computers to store vast amounts of data and compute faster and more accurately than humans. So the potential of AI for your firm is a right combination of humans and machines. So how can AI help finance professionals in a company? AI can impact your business strategy by helping the creation of more intelligent organizations. AI will not develop autonomously on its own. It is the humans in the organization who will create the improved interactions between humans and machines. The right people, combined with the right computers and systems, will create the most intelligent organization. To prove this simple point, a human being having access to Google search and Wikipedia is much more intelligent and capable than on his own. So AI applications vary enormously in scope and nature, and it's down to every company to work out what is best for them. In the field of corporate finance, I'm going to list a few now. So as a finance person, my mind is around the P&L. So on the P&L, you start with a revenue line. The revenue line is the aggregation of all the individual transactions generated by the invoicing department. Each individual transaction carries enormous amount of information on the customer, on the product, on the service sold, on the price, on the timing, on its payment, even the salesman, the supply chain involved, etc., etc. So this vast amount of data is what AI loves to absorb and exploit. By structuring the data in a proper way, AI can help you find patterns of behaviors and data structures to answer questions like, what is the price sensitivity of my product? What is its elasticity? What is the profile of the most profitable customer? What is the profile of the most profitable product or service? The most profitable geography, the best salesman, etc., etc. So the trends of the sales pattern can generate description of behavior and prediction of future trends or future tastes. From there, the company can be more proactive in developing new products or new services. So the data can be also cross-referenced to external information like weather conditions, if your products are weather dependent, or economic conditions, if you think about inflation, foreign exchange. You can also try to structure the data of your competitors' offerings and then match it with yours and see how it behaves. So another application is the cash collection process of your firm. It can be supported by an AI tool analyzing every customer profile and supporting the rebate applied to each customer, for instance, or the likely behavior for payment. The whole risk pattern can be analyzed and generate answers to be more efficient. Another example is a customer service department answering calls for potential customers. They can also benefit from automated chatbots. These are advanced speech recognition systems who try to interpret the questions raised by a customer in parallel to the customer service employee. The chatbot can then suggest answers to the employee to accelerate the answering process. At this stage, a chatbot cannot be on its own. I mean, the Turing test is not passed yet by artificial intelligence, so there must be a human to interface with the customer. I have a few more applications to share with you. For instance, image recognition systems can recognize a supplier invoice and key in all the necessary information on the invoice into the account payable systems in minutes. It can process hundreds of invoices in an hour, and by this saving a huge amount of manual work for your department. You can have smart data analysis to reconcile your bank accounts automatically. I mean, I've seen so many accounting departments, spending hours with people reconciling manually enormous list of data, which is so inefficient. So we can do it completely automated now with smart data. You can also allocate your cash. If you receive thousands of payments every day in your bank account, you have to match it back to your original invoice. So that also gets accelerated through AI. You can analyze your churn of your customers when your customers drop out. Is there a link? How can you explain the customer dropout? It's all linked to data analysis. Then there is the enormous field of forecast, budgeting. And here again, AI can help a lot. You have algorithm to forecast, and the accuracy of this forecast will be completely linked to the richness of your data and its quality. You can also associate KPI and dashboards with natural language processing systems. What it means is that instead of circulating dashboards and numbers, you can have a natural language processing engine who would convert all your variances into real text and real speech. Here I saw an example where a chain of restaurants, of hundreds of restaurants, usually circulated to their restaurants managers their weekly numbers on the dashboard, which was only numbers. But they realized restaurants managers didn't like numbers and they hardly read them or didn't like them. So with the usage of a natural language processing system, they could convert automatically hundreds of dashboards into words and explanation. And then they realized that the restaurant manager would then have a much higher percentage of reading them. So you can have also in the field of audit, lots of application of AI, where data analytics can be applied to bank accounts, accounts payable, payroll, to identify double payments or various frauds. So an enormous field here for audit. All these applications are immediately available. They are part of trusted and validated offerings from several software companies. The path to these achievements is to take the time to assess all different departments of the company and have an AI awareness to identify existing manual and repetitive work and replace them with smart solutions. So the next step for a finance director, it all depends on the maturity of your finance organization. If you run a finance ledger with Excel, I call it the lowest level of maturity. Basically, it means that your processes are all manual and they are not digitalized. And in this case, you will struggle to apply AI in your team. So the first step is to replace all manual processes and Excel-based processes by digitalized softwares, either by installing a fully integrated ERP. I mean, you can have extension of SAP, Oracle, Sage, Microsoft Dynamics, and so on. And you can also add layers of automation in your IT for managing account receivables, account payable, reporting, month-end close, tax, etc. You can automate all these aspects with software. Once all your processes are digitalized and Excel is marginal, then you can start exploiting your data and apply artificial intelligence. I think it makes no sense to run before you can walk. It makes no sense to apply a robotic process automation or AI if you are too dependent on Excel. Your process will not be robust enough. You will spend money inefficiently. As a conclusion, in my view, the digitalization of the finance function everywhere is a must. The use of all the generated data is a treasure of information. The progress of computing power, access to data, and ever smarter algorithm open up an infinite number of applications. So these techniques are not necessarily expensive. Some of these projects will have a return on investment within 1 year, but they are absolutely essential in my view. So in a competitive environment, the best performing companies will be those who understand and exploit artificial intelligence to their immediate benefits. Thank you very much.
Thank you, Guillaume, for getting us off in a fine way. And thank you too for having come up with the idea for this event and helping so much with its preparation. It's now time to ask Didier Hirsch to give his speech. He is a co-founder of the Franco-British Data Society and a board member. Didier.
Hello, everyone. I hope you can hear me, and for some of you see me. I'm going to go along the same lines as Guillaume and try to give you a few examples of how we use machine learning and artificial intelligence techniques in the world of financial markets. The reason why we can now talk about artificial intelligence in finance is because in many aspects, financial markets have become digital. Stocks, interest rates, segments of the bond market, as well as the commodity markets are traded on electronic marketplaces. And thanks to a lot of regulatory initiatives, trading liquid assets on markets, which are called recognized trading facility for the regulators, is less capital intensive for market participants such as banks. So as a consequence, we have a lot of opportunity to create large data sets of historical time series of high quality. And this is very good for us because our regulators, since the big financial crisis, have asked us to gather such sets of historical data. So some institutions have built them over time, but you also have data vendors who can provide you with very wide and very deep information. To name a few, you have Refinitiv that just got bought by the London Stock Exchange. You have Bloomberg, you have Market FactSets. And so for us market professionals, we can gather a lot of data. And as Guillaume explained it, computational power is everywhere. We have more and more available to us. So knowing that we have computational power and a lot of data, I'm going to present you with some example of how we use artificial intelligence on financial markets, focusing mostly on the activity of trading options and derivatives. So the first application is saving computational power and cutting costs. I'm going to try to provide you with a general picture of what we do. So in order to evaluate options, market participants use a model. Most likely the Black-Scholes approach to compute a theoretical price for an instrument. The Black-Scholes models require inputs such as the equity asset price, but also its volatility, level of interest rates, and from then on, we are able to compute what we call the premium of an option. And volatility is what drives the price of an option, but it is not a level that you can find in the market. It is what we call an implicit pricing parameter. So you have on one hand market prices, on the other hand a theoretical model for which you need to inject an implicit parameter called volatility so that the model and the market have the same price. So this action is called calibrating volatility. And that's what market makers in option trading do all day long. Once you've done your calibration, you can provide price, and those price will work on various characteristics of options, such as options of various strikes and maturity. But when the market parameters move, you need to rerun the calibration. So during a single day, our systems have to compute calibration on several hundred stocks and indices as soon as their price move. So it's easy to understand that the more volatile the market, the more calibrations are needed. So if you consider several thousand instruments that can be underlying to options, each of these instruments move every 30 seconds, you will see that option trading requires a lot of computing power. The numerical methods we use are easily distributed on vast networks of CPUs and GPUs. So it's very common to have 10 to 20,000 machines to support your operation. And these machines are dedicated to tasks such as the calibration, but also computing prices for clients, simulating stress tests to manage your risk and to compute regulatory estimate, and also computing the sensitivity of your option portfolio to various pricing parameters such as rates, asset price, asset volatility. And you can see when analyzing the day-to-day activity that for an institution such as a trading desk, computing has become a commodity and it has a cost. An institution must control those costs, especially if they want to expand their business. So what kind of solution can you find in terms of cost control? The first solution would be maybe to reuse all the heat generated by your computing farms to heat public amenities, swimming pool, office buildings, social housing. That's something we do. It's thanks to a French company called Carnot, which has developed computing heaters. So in other words, computers that also act as radiators, and they are installed in public amenities, and when banks use them, they can offset some of the costs thanks to the heat generated and provided to Carnot's customer. This solution has been adopted by BNP, by SocGen, and by Natixis. Another solution, which is more in line with what we discussed, is use artificial intelligence. So thanks to recent advances, we are now able to calibrate volatility surface very rapidly. We used deep learning technology, and we are therefore able to cut the calibration time and the product evaluation time by a factor 2 to 10. So this first application of AI for an operation like the one I work with has saved us 50 million hours of CPU over 1 year. In terms of green factors, it's 89 tons of CO2 emissions avoided. It's about 120,000 kilowatts per hour saved. And especially for us, we didn't have to buy an extra 10,000 CPU to grow our business. So directly linked to this deep learning technology, we are much more reactive in advising our clients. We can provide, thanks to the very good interpolating properties of deep learning algorithmics, price with variations of a lot of scenario at no costs. So for us, it allows us to be much more reactive and let our clients play with our system and build their own strategy without having to spend a lot of time computing. So that's very cost efficient. A third application of AI is in the field of risk management and bank capital management. So the banking capital regulations require banks to run stress tests and loss distribution computation on their portfolio in order to determine the amount of capital buffer required to run the business. This is a regulatory obligation. Figure must be produced in due time. The business line must operate within its risk limits. And this is also a time-sensitive process. The levels have to be produced daily. If we have exceptions, if we cannot compute, there's an escalation process up to the bank's management, and after a few days, if problems persist, to the supervising authorities. So a bank typically must compute their value at risk on a daily basis. The value at risk is a statistical estimate of the worst loss that a bank or an institution can expect over a certain period of time before it can sell its risky position. It's a statistical indicator, so there is a confidence level. You need to set a time period and a liquidity horizon. For example, a 1 year period, a 99% confidence level, 10 days to sell the risky position in the portfolio. So in order to compute value at risk, you can estimate it using random simulated stress test scenario. It can also be estimated on historical scenarios using data and time series of the value of the risk factors in your books. It can be computed using the sensitivities of the portfolio. It can be computed also by fully repricing each scenario on your portfolio. So you can see that it can be very computing intensive. Simulations require maybe 10,000 or more scenarios to converge. Full repricing is very costly if you have many thousand options in your books. And the use of sensitivity is problematic for extreme scenarios when there is a high probability of divergence between the portfolio value and the prediction by its sensitivity. So banks tend to compute a historical VAR using a full repricing approach. So typically it's something like a 1 year, 99% 10-day VAR. If you take, for instance, the computation of this estimate on 300 historical scenarios, you need to compute those 300 scenarios on your current portfolio. You have to rank the impact of each scenario from the biggest loss to the largest gain, and the VAR amount will be the third worst loss. If you could guess the rank of a historical scenario before you have to compute its impact, you could compute your VAR in one full repricing. So you can see that there is a real something at stake if you can optimize your VAR computation methods in order to limit the number of scenarios that you are going to have to compute before you can produce the official figure. You can definitely increase the robustness of your daily process. And for the front office, with regard to capital allocation, it's much faster and much leaner to run what-if scenario. And so you have a better cost analysis process ahead of taking any further risks in your book. So there too, we use AI techniques using the preceding computation, learning the risk factor driving your portfolio, and we can save a lot of time, and we can have less people looking at our processes in order to provide our regulatory levels on a daily basis. And a last aspect of where AI is really important is in the data governance of the time series that we need to produce our prices. And this is in the context of a new standard for banking capital regulation that has been set by the Basel Group and which is called Fundamental Review of the Trading Book. It's based on the fact that product valuation, product risk management, and product accounting standards must converge. You cannot have a separate data set to compute your P&L, value your book, and estimate the risks. So banks have to put in place a very complex set of data acquisition process in order to create what we call a golden source of data used by all the departments, trading, risk monitoring, accounting. And the buildup of this golden source means collecting millions of data every day to monitor the large number of risk factors. And I'm quoting a survey by Ernst & Young. Basically, small banks, regional banks, have to manage around 100,000 time series on a daily basis, whereas global banks will have to manage close to 1 million time series per day. So the greater the number of risk factors you have, the bigger the data analyst team will have to be. And so most banks explore a lot machine learning techniques as the future of their market data operation when considering data quality, reviews, and correction. We think that AI can increase the productivity of data analysis. And this will be something of a great importance in the coming years, especially when the regulation becomes live.
Thank you, Didier. That's a wonderful way to conclude a really interesting overview of everything that you and your bank get up to. It's now time to hear from Ed Peake, who will speak about all this from a different angle. Ed.
Thanks, Mike. Yeah, indeed. So just as a word of introduction, so my name is Ed Peake. And if I were to sum up my job in one sentence, what I do is my job is all about building tools in order to facilitate decision-making processes and how to use the outcome of these tools in order to operationalize it into into key actions and what needs to happen. So over the next 10 minutes or so, I'll be talking about the application of AI with a specific case. I'm going to apply it like to human resources, and I'll link it like to the financial implication. So why human resources? Simply because at the moment, this is the industry I'm working in, and also because AI is having a great impact on human resources. Why is it different, like from other, like for example, when I heard Guillaume or Didier talk, why is it different, like from their fields? Just because we deal with colleagues' data, so people data, and it's very common to realize that we do have unconscious like biases within our processes. So what do I mean by unconscious biases? Unconscious biases would mean that you tend to favor or disfavor like specific groups of individual. So what would that be translated into is, for example, I do have an organization, I do have two people evolving at the same rate or doing the same type of job, but one is younger than the other, and it might be possible that this person might be treated differently just because of the age difference. And what would that mean? So that means that thanks to the AI, you'd be able like to provide like the type of change like to avoid this type of situation. So in many cases, like AI will allow you like to both identify what would be these unconscious biases, but also provide alternatives as to how to solve them. And today I'm going to talk about a very specific topic like for HR, which is pay equity. So the definition I use for pay equity is quite simple. So ideally, it would be to provide equal pay for equal work. So this topic has been getting a lot of attention over the last few years. Why? Because first of all, pay is a sensitive topic and it is a complex question. If I were to ask two employees what working for the same organization, what would be the pay compensation structure, it's very likely they would give me different answers. So they would give me different answers as to what would they think the list of drivers in order like to calculate one's pay would be, but also what would be the importance of the factors. So in that case, that would be the coefficient attributed like to these drivers, and even on the type of equation or the type of model used in order like to understand and calculate what their salary would be. And it's very unlikely that one would get right within a company. And I think this is exactly where AI can help, where at least what you're coming up with is a systematic way of understanding what is currently impacting your pay compensation structure and helping employees like to understand it, like making your companies transparent and making sure that all employees are being treated fairly. So as I said, like what would be the incentive like for an organization to do this? So if you think of pay equity, it's more likely that this will result in a costly exercise because as you find gaps, so what would be the gaps? The gaps would be the difference between whatever like the model predicted value would be for an employee versus like the current salary. It would be much easier like to correct people that are currently underpaid. Why is this? Because if I think about the problem the other way around, it's a lot harder like to limit someone's salary to say, Ed, actually, you're getting $200,000 and we can see that you should be getting 150. Therefore, I'm going to lower like your salary by $50,000. I mean, hang on. This doesn't sound fair, so I'm not going to tolerate this. However, it is important like to understand and identify that yes, there might be some discrepancies. And also, why would I be doing this? Just because in most industries, and especially like service-focused industry, headcount represent one of the largest expense. And it often costs more like to recruit new employees as opposed to keep someone who's been performing well over the years. And doing such exercise like impact the attrition rate. So what do I mean by the attrition rate? It means like your employees that tend to stay longer within the firm and therefore diminish like the price you would pay for your headcount base. It's also very important like for an inclusion and diversity perspective, so IND. Why? Because when I was talking about unconscious biases, it's also important to identify if there's any that could impact your compensation structure. So for example, gender at the moment is definitely like a big like topic. because let's say I develop a model and I can see that gender helped me in having more accurate predictions, like for my salary. Should that be right? That's a big question. And at the moment, personally, I don't think that it should be right, but at least it's important first that we identify this. And second, then once it's identified, then we can offer a solution to this. And related to this point, there were a couple of famous legal actions that were taken when people were not compensated in the same way as their colleague. That happened like in 2017, for example, with the BBC legal case, when unfortunately it was discovered that a female reporter earned less than a male counterpart when they had exactly the same level of experience, when they had exactly the same type of responsibilities. But I can't remember exactly how big the difference was, but it was substantial. And these processes ultimately can make it more transparent, ensuring that people are treated in a fairly same manner. And also that would minimize the risk from legal perspective, ensuring that yes, you are not carrying forward like this unconscious bias. So what are the outcomes that you could expect from a pay equity analysis? So first of all, you would be able to understand what drivers are impacting your current pay structure. And then the next item is really understand what would be the projected pay for each employee to compare against the current pay, to quantify how big the gap is. So understand what the drivers should be impacting pay. So this is a critical step within the process, because this ultimately really much depends on all the data you've got available and all the data that is around there. And this is, again, another area where you will need to bring consistency, because I would expect pay equity should not be done once within the lifetime of a firm. This should be a regular exercise. So therefore, with everything that is regular, it should be automated as much as possible, in my view. Why? Just to make sure that you bring consistency and robustness to the highest standards possible. And during this phase, what we need to do, you would need to work with across various teams in order to identify what could and should impact pay. So for example, in could, I'll go back to gender. I don't think gender should impact pay, but I think it could. Therefore, it's extremely important to bring that in. I also include things such as, for example, grades. Why would I put grades? So what do I mean by grade? Grade would be, for example, I don't know, if I think about my previous work when I was in EY, there'd be the different levels. So whether you are an analyst, a senior analyst, a manager, a senior manager, director, a partner, and then the different level of partners. What is this? Because this will give you a fairly good understanding of the level of responsibility that an individual would have. And other things that you would need to take into account would be, for example, the performance. Have they performed over the last few years? What would be the different job family that they have or functions? So, for example, does someone working in HR should get exactly the same kind of money as someone having a more client-related type of role? And all of these different factors. And doing this and putting this into a kind of a sort of AI model will help you to understand what could be the factors that do have an impact. It's very possible that, for example, as I quoted before, performance might or might not have an impact. It might be even different depending on the different segments of employees that you have as well. And this is really where it's important to understand how you'd like to structure your data, but also what is the type of thing that you would want to get out of it. Because, for example, if gender is a part of your driver list and is statistically significant, so in that case, you would use the p-value in order to understand this, you may want to investigate this further to assess how much of an impact it has by looking, for example, at the gender, at the coefficients assigned to it, but also what could you potentially do in order to remove this without impacting performance. So what I mean by performance in that case, I mean the accuracy of the model. And when you have made the distinction between these two categories, between what should and what should not be impacting your model, then you'll be able to go to the next step and go forward with what definitely should, putting aside like gender and so on, in order like to understand, all right, what is currently forming the base of the compensation structure. Having done this, you will make sure that actually you're not carrying forward any of these unconscious biases that I was mentioning before. And this model like will help you like to consider how to treat colleagues like fairly and in a robust manner over the years. And when you've finished this, when you have identified all the different drivers that should impact, when this gives you like quite a good idea and actually makes sense like to the people. So in that case, I guess that would be the different HR people that you partner with. You'll be able like to come up with prediction as to like for each of the employee in your data set to understand what does it mean and how that compares again the current pay. So of course, I mean, I'm not going to drill into like what should be the processes after this, because this is extremely complex and this will vary organization by organization, because what you can come up with is different techniques to identify who should be most corrected. So for this, what would companies tend to do? They will tend to put threshold in order to see how your current pay varies again the projected salary, in order to understand, all right, by how much then would I need like to bump these people's salary in order like to tackle these issues and make sure that people are getting treated in a similar manner. So now, what are the different challenges to take into account when you develop these kind of tools? So first of all, the big one, there's data quality and even availability and completeness. Because especially when you tend to do this for a large organization, the data might not exactly be in the same structure. Again, you'll be able like to use different AI techniques, ML techniques, in order like to come up with something that is as consistent as possible. But I think this is something that is really important to take into account, especially if you were to work for a big organization, let's say an organization that's got employees between France and the UK. You might have a lot of differences in how people are being graded, what's the type of responsibility, or even like the type of job description might be different. Then the second one is really like the segmentation about the data, because when you start to look at the data, like you need to understand, all right, I do understand the drivers, but even when you do have drivers, you need to make sure like from a statistical background that your population is big enough, like also for each of the drivers. So for example, if I can say, all right, I can see that for people based in the UK, language like seems to have a good impact. However, I can see that across my 1,000 of employees, I have the data only like for 4 of them, and I can see, yes, it impacts it positively. And actually people having dual language skills seems to be compensated in a better way than people having only one language. However, just because I got only 4 employees for which I have the data, would that be sufficient? Probably not. In that case, it's also like the iteration process of making sure that, yes, you do have enough data and you do have sufficient like volume of data to ensure that this will be correctly calculated within the model. Then the next one is, and that's really important, so when you finalize the model, when you've got something that you think you're happy with, is to understand whether you are potentially under or over predicted, like a specific cohort of employees. So what I mean by this, let's say I develop my model, everything seems to be good, like from a statistical background, everything like written something like honest and I think I can believe. But when I start looking at specific like pockets of employees, I can see, for example, people working in data seems to be a lot less underpaid in the model when compared to, I don't know, someone working, let's say, in legal. And what is, so that doesn't necessarily mean that's wrong, but that may mean that at the moment, maybe you're missing something in your data and is impacting specifically like the data people in this case. And therefore, there's a lot of iteration like processes that need to happen in order to make sure like this does not happen. And ultimately, like what's probably like the most simple way and the best way like to tackle this type of issue is to look at the different segments of employees. In that case, segments like would be the data quality, the data people, in order to look at the variation between the current pay and the projected pay, because the average ultimately should be quite close to 0 over the group.
And then, could
yeah.
you begin to start wrapping up, please?
Yeah, of course, I was going to do this.
Thank you.
No worries. And then to conclude, I'll start saying that this model like will never be perfect. You will never have like 100% confidence in the suggested pay. In my view, it's important like to keep into account that at no point like we should suggest that people should align exactly to the projected salary. This also like should be complete with a very strong audit in order like to understand whether like, we've taken everything possible into consideration, and you might have things that are not listed in your model that may explain the discrepancies. And also, and this is another tricky question, is to understand what would be the consistent part with the external benchmark. So after doing this as well, like it could open like a new world of possibilities where ultimately you can use the outcomes like for things such as understanding what would be the expected salary like for all new hires in order to ensure that you're not widening the gaps over time. There you go.
Thank you very much indeed, Ed. That brings us now to Christophe Le Lannou, who is the president of the French side of the Franco-British Society, Franco-British Data Society, and the co-founder of the society. So Christophe, over to you.
Hi, thanks, Mike. Can you hear me all well? And I'm sharing my screen as well. Can you see my screen? Oh no, share, sorry, share. Can you see my screen now as well?
Yeah, we can see.
Thanks a lot.
Yeah.
So good afternoon, everyone. I am Christophe Le Lannou, and so I'm speaking here today as well as a consultant of dataLearning. dataLearning is a consultancy firm specialized in data. We are helping our clients, both based in France, in Paris, or here in London, to have a better use of their own data. And so I'm going to do my presentation here today around, I think, 3 main slides. I'm going to first maybe review the definition of artificial intelligence and machine learning, before as well speaking about my experience with control functions, especially like risk management and audits, and how they evolve, how their works evolve over the last, even the last few years, and how their process as well are evolving currently. And I'm happy to take any questions at the end of my presentations. So what is artificial intelligence? What is machine learning? As well, both terms which have been used a lot as well today and are used a lot in the press. And there are as well a lot, very often people confuse them as well. I think a good definition of artificial intelligence is a system that perceives its environments and is able to take actions to achieve a goal. So it's kind of intelligence demonstrated by machine, which are able to do something like we, as human beings, are considering need a collective effort. We need to work on to think about it to be able to do it. So I think some good example of artificial intelligence in this case will be currently understanding human speech, automatic cars will be good examples. Whereas machine learning is more a specific branch of artificial intelligence that study computer algorithms and are using experience and data to make their predictions. So machine learning is based on mathematics, statistics, advanced statistics, and sometimes as well some biology with neural network, for example. Some output of machine learning will be image processing, video recognitions, email filtering, all these kind of actions which are a result of advanced algorithms. And I think at this stage as well, it's interesting as well to mention the AI effects. And actually, the definition of AI is evolving through times as we, as a human being, are progressing on this field. So AI actually is more defined as something we have not been able to do yet. So we're not very good yet at understanding human speeches. We're not very good yet at driving cars. But once we have done it, actually, people think it's not regarded as intelligence. So I think one of the first examples of this will be Deep Blue, who famously beat the world chess player in '97. And then everyone else as well start to criticize Deep Blue as just being a brute force. He was not clever at all. He was just kind of trying every single possibilities. Then afterward, nowadays as well, you get optical character recognitions, which just maybe 5–10 years ago would have been kind of incredible to be able to recognize handwritings. And nowadays as well, it will be kind of course number 2 in part 2 in a course, a Python course. So very easy, very basic things to do. Nothing at all very intelligence. And the last example, I think as well, which make a big impact was in 2015, so just a few years ago, with AlphaGo beating the world champion in Go. This one has a big impact actually on China, where the game is very famous, because Chinese people consider Go as being one of the most clever game. And so to be able to play Go, you need to be intelligent. So the fact that the machine was able to beat a player was something very big for them. And that's what triggered as well, or one of the main trigger, I think, of the artificial intelligence revolution in China. That was a big wake-up call for them. So having said that as well, so if artificial intelligence is something we are not really able to do, what does it mean for us as well as consultants as working in companies to be able to apply artificial intelligence? But I think here is a bit kind of playing with the world and is more to be able to use ingenuity and all the technology and the system which are available to us to be able to build complex platforms. So I think Didier mentioned some of them, Ed or Guillaume, they all mentioned as well in their own fields how they were able to build complex platforms which are behaving like a bit intelligent system. And I'm going to use here in my speech as well the case of risk control functions, because we are more in the financial world here today. And I think in the financial world, most of the entities are regulated, and to be able to control them as well is very important. So risk managers, auditors, are directly concerned as well by this transformation and the development of this digital platform. They need first to evolve as their clients, as their users are evolving. Their users are producing more and more data, more and more complex systems. So they need to be able to analyze them first. So we are very far away, like I think, remember 100 years ago, audit or control was all about physical visit to branches, to local, to open drawers and open boxes to find some of your paperwork. So all this time are passed for them as well. And nowadays, they need to be able to look for anomalies, to monitor all the data flowing through the financial world, basically, also through the entities. Another reason as well, they need to keep evolving and to stay up to date in the technologies. They need to be able to provide efficient solutions. So they can't be staying as well in Excel. I think like Guillaume was mentioning earlier on. They need to be able to evolve and to exploit more and more efficiently the data on they are given to analyze. So that's the context as well for the evolutions. And so which kind of process as well are involved? I think as well, I would like to mention as well that actually all the processes are involved. Initially, a few years ago, everyone was speaking about fraud detections, money launderings, because this was evolving a huge amount of data. As you can imagine, working for large banks, you get thousands and millions of transactions an hour, even a minute. So to be able to detect some fraudulent transactions, need straight away to move into some kind of big data infrastructure. But actually, when they keep working and throughout the years, they are discovering as well that this technology needs to apply more and more widely to every kind of control they are doing. Whatever they are auditing, as I said, cash flow or financial models, but they need as well auditing human resources. I don't know, in France, maybe ticket restaurant allocations, which are kind of very specific analysis they need to do. And they need to be able to do it very efficiently. So they need to build as well their platforms to be able to detect straight away and to analyze straight away this kind of data sets. And that's how this is happening as well. This evolution is happening. I think it's a lot about going away from Excel. As Guillaume mentioned initially as well, I think Excel in a kind of a way is a trap, because a lot of people are still doing the analysis in Excel, but Excel is not at all a perfect way to analyze a perfect tools, and doesn't provide the good functionality to analyze your data. Excel is a very good system, very open and very flexible, but you can't make an automatic process and scale up your analysis within Excel. Anyway, in Excel, you are stuck because even you cannot share your Excel with anyone. Whoever understands an Excel developed by someone else, as soon as you start to work on your own Excel, it's kind of becoming unauditable. And so basically, around these things, all the team needs to start to evolve. And the fact as well that their work as well is starting to evolve, and the way they are doing their work is starting to evolve as well. Where before, for example, auditors as well were even a couple of years ago, 2, 3, 4 years ago, and some auditors even currently, are still working a lot by sampling. So they are trying to analyze a sampling of the data. They are not able to extract all the data, so they are just working by some subsample of 100 data sets, 100 data points. And they start to work, and their audit is to work around them and to analyze them. But actually, nowadays, they need to be able to do a global analysis and to build the tools and the platform to do this. And that changes as well their workflow as they go along, because their workflow now starts to be more around data and preparing their data, working around their data, analyzing their data. Whereas before it was more around sampling and simply going through one data at a time. And so that means as well, I think on this, so a better use of technology, but as well a better use of your resources, your human resources as well, and the need to keep training your people. And I think to develop AI and a digital platform, you need to keep training your people to new technology, to new way of doing things, so that they are getting efficient and catching up with all the latest developments. So training is very important. Another thing which is important in this process, I think, is a certain lack of control, like it used to be exercised before. As well, here you are moving into a world of uncertainty. We discuss a lot about statistics and probability, at least in ED talks. And so when you move into this world, you don't know for sure the outcome. So you need as well to be able to to get some flexibility in your processes and adjust in a constant way to your process. So that's why I was trying to represent by this drawing on my right, this kind of virtuous cycle, where you are trying constantly to permanently to adjust your process to your results. So you get your software factory in place where you are developing your codes, improving your platform, observing, and then you need to observe and collect data from your users to be able to keep improving again and again. The last things as well I want to speak about as well is not only about the way they are doing their works, but how their work itself is evolving as well currently, and the specific challenge risk management, auditor, compliance people are facing as well, because at the same time, the way they are doing their work and they need to is evolving. They need to be able to monitor the way their user work is evolving as well. So if their clients are human resources with algorithm to compute your salary, if their clients are, their users are financial people with deep learning algorithm, or if their users are the financial department trying to do some financial predictions, they all need as well now to monitor these new tools, this new platform, and to develop the know-how and the expertise to control them efficiently. And that's a subject as well, which I think has not been widely discussed yet, but is slowly taking place. So what is going on here is that actually when you're speaking about AI, you are speaking about a computer taking some decisions. So it's kind of a black box taking decisions and replacing a human process by a computer. So when you think about it as well, this involves as well a lot of risk, both in terms of ethics, how is the computer going to do it, and efficiency. So I think here I would like to mention as well, so the different expertise people need to deploy, especially around the machine learning algorithms. So they need to develop as well the knowledge and the expertise to control, to see how their users are working around their data, how they are preparing the data, or the treatments they are applying on the data. And mention this as I think a little bit. The performance of the algorithm, of course, as well. I think these both subjects are kind of widely known and done as well in general. But the next two as well are very important, which are stability and explicability. So stability is the fact as well that you need to monitor your algorithms through times. It's not only when you start to issue a new algorithm and you put in production a new algorithm, it all looks good, so that's fine. You can switch it on and go away, and the computer is going to do all the works. No, you need to have system in place to ensure that your computer keep working well throughout time, and the decisions taken by your computer are still the good decisions. So that need to set up some specific process. And the next subject as well is explicability. So explicability as well is to be able to explain these black box results and to be able to understand them. Otherwise, you're not able to judge or to measure the performance of your algorithms. So all these four axes, these four category of machine learning evaluations, from data preparation, performance, stability, explicability. So they need to be monitored both via the permanent control, risk management, and audit. So the permanent control are the people which are controlling on a daily, weekly basis the system. So they need, of course, to monitor when a new system on a new platform is evolving, which we discussed before, is kind of on a continuous basis. You get a new improvement, new advance in their platform, but as well continuously monitoring, having maybe dashboards, having some kind of business intelligence tools to be able to monitor on a daily basis the progress of their algorithm. And the final subject as well to mention is auditors. So auditors are the people which are coming to analyze your systems, not on a regular basis, but irregularly, maybe once a year, once every 2-3 years. And these people as well need to develop some kind of specific knowledge now and expertise, both technical, to be able to technically analyze your digital platforms. So to analyze your code, to analyze your methodologies, to analyze your documentations. But they need as well to get the business experts, which are able as well to discuss and to challenge a black box and to analyze how this box is performing. For example, going back to Ed's example on human resources, he was mentioning about bias, gender bias. You are mentioning as well all these different age, gender, all these kind of important ethics which need to be taken into account into your system. So I think to conclude as well here, I would like to say that so artificial intelligence is evolving every function in a company, from finance, risk management, business. They all need to be able to face their user and to better exploit the current technology and the current tools available to build some efficient platforms.
Okay, Christophe, is that you finishing?
Yes.
Well, thank you very much. It's now time to throw the questioning open to the floor. When you speak, would you don't have to, but it might be nice if you would say who you are and what you do, whether you're a student or whether you work in business, and if so, in what capacity. So any questions? Well, I'll start with a question then while everyone else is gathering themselves. One particular issue seems to be the continuing legacy use of Excel. And this is an example really with, will people be able to comply with regulatory requirements applicable in the finance industry if they keep going with Excel? Because after all, regulation requires that companies are proceeding on the basis that they know their data, it's correct, and it's explicable. Guillaume, do you have a view?
Yes, certainly. I'm not sure I know exactly the regulation on this, but I think, as I said, I mean, Excel being open, and Christophe also mentioned the fact that an Excel is usually only understood by the one who has built the spreadsheet. So if you share your spreadsheet to someone else, he will never really get into the depth of the understanding of the original creator. But once you have Excel done and has produced some kind of analysis, you can put it into a PDF, which is then frozen, and eventually you can use it for an audit. And that we do in the corporate world when we do the year-end audit. Lots of documentation to justify our accounts could be frozen Excel spreadsheets. But as I said during my talk, is in my view not efficient. I mean, it will be very difficult to erase Excel completely, but I think we need to make it a marginal tool for the stuff that is not formalized in a proper process, in a proper software, in a proper ERP. That's my view.
Thank you. Okay, anyone got a question? Anne, maybe you should unmute everybody unless you've already done that, and then don't all speak at once. So, any question?
Trying to understand how to unmute everyone, sorry. Otherwise, you can be easy for people not to.
Hi guys, I'm Julian Marshall. I'm in the financial risk management industry. Quick question: those techniques. I mean, some of you mentioned some techniques. How wide would you? And I'm not sure who this question is addressed to. How wide would you say machine learning and deep learning are actually used in finance? I didn't hear about asset management, for example, or other sector of finance. I don't know who would want to take the question.
I'm happy to get the first go. They are starting to be more and more used, I think, month by month. And at least because people are building, so the risk management or the auditors as well are building their digital platforms and their tools to access, especially maybe to access the data. And once they get access, they get this platform in place, they start to apply some kind of machine learning, or they're at the beginning of the process, to apply some machine learning algorithm, even to detect where are the anomalies, where to look. So people are on this field, according to my experience, people are slowly building, yes, their workflow, their automatic workflow, collecting data on building dashboards and tools to be able to get some even advanced informations. And these tools could be based on some kind of advanced machine learning algorithm. Does it answer the questions?
Julian, do you want to come back on that?
No, sorry, I messed up. Thank you. So it looks like at the moment it's more about data and trying to make sure we actually have the right data, and that's the first big hurdle, no?
Yeah, exactly.
Not only the right data, is to get the right platform. Once you get the right tools on the right platform, then you can start to exploit this the data generated by your platforms. So I think there's a lot of people as well, a lot of risk management teams are still in the step to get away of Excel. So most of them are not well advanced in the system.
Okay,
I guess more digital banks are more advanced in the system. And they need to build this kind of automatic tools to detect and to monitor things. So to get away from the daily monitoring of events to more monitoring globally their infrastructure and how they monitor events.
Thank you, Christophe.
Okay, next question. If there are not going to be more questions, this is really a kind of lunch hour seminar, and it could be that going past to 1.25 hours is too difficult for everyone. So if you do have another question, please say. If not, what I will do is to thank you all, in particular the speakers, but especially Anne Bioche, who is the secretary of the Franco-British Data Society, who's done a lot of work in pulling this all together. And our audience, thank you very much for joining us. Please comment on LinkedIn about this event if you would like. It's always very helpful to get feedback, and you might even include in your feedback potential future talks that or seminars that we might put on. So with that, I'll wish you au revoir.